So the IP address can be classified into three values, right? There are classified as Class A, Class B, and Class C networks. So 3XXX, right, that specifies a network group of 2 power 24 minus 2 hosts. So the maximum number of systems available in a 3XXX case is actually 2 power 24 minus 2. And the XX specifies 2 power 16 minus 2, and 1X specifies 2 power 8 minus 2. So the number of systems available in each and every type of network. And the first case, Class A network will be having a structure of n.x.x.x, where x is between 0 to 255 and n is between 1 to 126. This is because the MSB bit, right, that is the bit 31 is always kept as 0. So the maximum value of n will vary from 1 to 126 only, right? So that is actually the maximum range available in that. So the remaining XXX can vary from 0 to 255. So what is the maximum range here? 1.0.0.0 to 126.x.x.x, where x can range from 0 to 255. Class B network, the general format is n.m.xx, where x can range from 0 to 255, and n and m can vary from 128.1 to 191.254, right? So the maximum value is 191.254.x.x, with x ranging from 0 to 255. Why this is? This is because the IP address 32-bit has two MSB bits, that is the 31st bit and 30th bit should always be 1 and 0 for this Class B network. Then we will see Class C network. This will be having a structure of n.m.k.x, where x ranges from 0 to 255, right? And nmk, this can vary from 192.0.1 to 223.255.254, right? So the minimum range is 192.0.1.0 and the maximum range is 223.255.254.255. X can vary from 0 to 255. So this is because the IP address of the 32-bit has 3 MSB bits, that is the bit number 29, 30 and 31 should have the value of 110 for a Class C network. And since we are going to have only some 8 bytes, right, that is available, right, for the IP address, and the number of systems keeps on increasing, the IP address range may not be sufficient to hold all the computers. So in that case, what we can do is we are going to have a dynamic IP address, right? So a number of computers or laptops or devices may need connection and organization to an IP router. And the number of actual router at any instant may be much less, and in this case, say for example, the actual IP address range is available only minimum, but more number of users are available, so more address need to be provided. In that case, actually what happens, we are going to have this dynamic IP address, and once a device is connected to the internet, it needs to be allocated with the individual IP address called a dynamic IP address. Now what happens, it will be dynamically assigned. And when the device connects to the router and the device use the DHCP, that stands for Dynamic Host Control Protocol. This will be giving you a temporary dynamic IP address. Once the connection is removed, right, then this IP address will be assigned to some other computer, right? So whenever you are connected, you will be given some IP address, and when you are disconnected, the that IP address will be given to some other persons. Right. Supposing you want to have a permanent or static IP address. So in that case, you have to pay some extra amount to the internet service provider so that you will be getting a one permanent static IP address for your system. That is also possible. And the domain name system, it's an application which provides the IP address for the corresponding service from the named domain service. Say for example, instead of memorizing the IP address, what we can do is we can have some domains, something like google.co.in, that is actually a domain. And in the example, they have given an example, that is the author of the textbook for our subject, that is rajkamal.org, that is actually the domain name. And this domain name will be assigned to the IP address 198.136.56.2. Now since this is fixed, we can call this IP address as a static IP address, because whenever you put 198.136.56.2, it will always go to the rajkamal.org. Supposing if it is a dynamic IP address, this IP address may take to some other websites also. But since this is static, this web server, this domain is permanently assigned to this particular IP address. So this is actually a static IP address, we can say. And since the number of computers is exceeding threshold, and also we are connecting the IoT devices, right? Each and every person will be having more number of devices. Say for example, we have a smartwatch, we have 2 or 3 mobile phones are there, tablets are there, then your laptops are there, and in addition to that you will be having some smart devices like smart door is there, or in the household there are some smart lights are there. So the number of devices connected to internet keeps on increasing. So this IP version 4, which can have a maximum of 32 bits, may not be sufficient to address all these things. So in order to address this problem, the IPv6 address actually has been formed. Now this IPv6 will be having 128-bit address against the 32-bit address size of this IPv4. Here actually what happens, a hexadecimal represents 4 bits, right? So 0 hex, that is 00002, F hex, that is 1111, right? And it is a 128-bit address, which is a 32 hexadecimal digits will be there. So 32 hex, each and will be, everything will be having 4 bits. So 32 into 4, that will be forming the 128-bit address. And we are going to have 8 sets of 4 hex digits, right? Each is separated by a colon or dot. So we are going to have something like that. 8 hex digits, 4 hex digits will be separated by a group. Something like that. The example is given here, like 0 ACB colon 8A00, right? So you can see 4 hex digits are combined together, and you will be having 8 such data will be available there, right? So this is actually the data that is given in the IPv6 addressing. So the IPv6 can also be classified into 3 classes. Each class differs in the primary addressing and routing methods, and interface may be a distinct node. What are the features of this IPv6? So since we are going to use 128-bit data, it addresses a large space, right? A large addressing space is possible. It permits hierarchical addressing. So we can have some priority, which packet should be given the highest priority, and the hierarchical addressing is possible. And it provides additional optimization for the delivery of services. So some optimization techniques are also incorporated in order to find out the shortest path, right, or the safest path, we can say, and along the subnets and interfaces also. And device mobility, that is again a very important point, right? Most probably whenever we are going for some IoT devices, we are going to carry on our mobile phones. So the mobile phone will be connected to one tower, and when we move to the other range, other area, it will be connected to a different tower. So the mobile will keep on moving from one place to some other place. And this IPv6 will take care of the mobility. And also it ensures the security and the configuration aspects. Each and everything, it has to be dynamically configured when you move from one tower to another cell tower, right? Cell phone tower, we can say. And the expanded and the simple use of multicast addressing. Say for example, from one data we can, or from one mobile we can transmit the data to many mobiles, right? That is actually called as multicast addressing, right? And jumbograms. So with the normal datagram, we can increase the size of this jumbograms, right? And the extensibility of options, we can extend the options. There are some reserved bits are there. Using that, you can extend the available options in the IPv6. I think here we will stop here. We will continue this in the next class.